Hi, I'm part of Intel Labs, and I'm part of a fairly new energy systems research lab at Intel. And true to what we've been talking about here, we are a really diverse group of people. We've got power engineers, we've got high performance computing types, we've got networking, distributed systems background, sensor designers, social scientists, all coming together, not quite understanding how to communicate with each other, but learning slowly. You could imagine that at a place like Intel, there are vast armies of people looking at energy efficiency on, you name it, any part of the system, chip design, so forth. But what's different about this particular team is that we call it energy systems because we're not so much interested in the energy efficiency of, say, one platform, one laptop, one server, one notebook. But rather cooperatively looking across a whole collection of devices or entities. Those entities could be devices or sensors or homes. What could you extract? I mean, you could have some collective objectives, one of which might be energy savings. So that's the purpose of this team, kind of emergent collaborative behaviors, if you will. I also wanted to set a little bit of context about Intel because even though people have put up some charts about who's in this area, I haven't seen Intel's name there, and which is very intriguing to me. It sort of makes me want to go back and say, you know, we need some more dollars thrown at this. We need to be a larger team. We need to be more visible because no one knows we're there. But suffice to say that some people noticed the EPA for the last 3 years has recognized Intel as being the largest purchaser of green power in the United States. And it's likely to be a fourth year because this year I think Intel is committed to buying renewable power on the order of, like 2.5 billion kilowatt hours. And what that amounts to is about 85% of what Intel uses in the United States in terms of its electricity. In addition, Intel is a place where one of the human aspects I think that we have been talking about a little bit here is how to affect change. Intel from the top decided we're going to tie our employee bonuses to our ability to reduce our energy usage by 5%. What does that mean to a company like that? I mean, you're talking about a 100,000 person company. And so there's a vast array of things that have happened, everything from, the IT department, which manages about 300,000 machines, to look at efficiencies there. Our fabs, you can imagine the resources that the fabs use. It's all about water. Our carbon footprint is largely about water usage. And so the metrics that they're using is the reduction of our carbon footprint and our energy consumption, electricity consumption. So anyway, so that's the context within which we're doing our work. Let's see. I was told I had sort of 6 minutes to talk. So I thought, why don't I try to point out just a couple of interesting opinions. One is a recommendation around long-term trajectory that I haven't heard a lot of discussion about, except I think that Ty Zanotti was a plant in the audience because there's this discussion, a lot of discussion in the smart grid around energy efficiency. And why aren't we really talking about the more compelling and provocative notion of self-sustainability, and in fact go back to first principles, which is when we were growing up, we were told, you only have a certain amount of money and you can only buy with your allowance, whatever fits into that budget. Well, why do we have a society that basically allows us to spend, to consume more than we generate and store? So I haven't heard enough discussion here about trying to fit ourselves into a really sustainable, that's the definition that I like to go back to. And so one of the things that we're looking at is look at the architecture of the smart grid and try to understand, and using IT to analyze, because we're tracking all the behaviors and usages and so forth, could we make a recommendation about what collections of things could form a scoped, you could call it a microgrid or a picogrid, a nanogrid, whatever the size, that is fairly, that supports equilibrium of some sort, probabilistic equilibrium. So those are some of the discussions we're having. And in the process, we're trying to consider not just what the US-centric viewpoint is of the smart grid and its architecture to support something like that, but consider what's happening in developing nations, because they represent about 1.5 billion people who don't have electrification as yet. And from a place like Intel's perspective, that's a huge market opportunity. But there's another reason that these sort of, separable, off-grid, islanded microgrids make sense, which is they are interesting because they're robust, hopefully self-sustaining at some point in time, both in developed nations and then developing nations. Developing nations don't have an infrastructure. They don't have a reliable infrastructure. So if you solve that problem here, you could apply it there, because their grid is going to grow from the inside out. There's another reason to consider developing nations, which is that if you look to what happened with the wireless cellular infrastructure, it really catapulted itself past what we already had in place, because we were looking at propping up our telephony topology and infrastructure, when in fact maybe we just needed to look at something new and different to support that. And so the question here is really to go back and say, okay, what if we could approach this with a clean slate? What kind of architecture would we really build out? And this really applies to a whole range of things. When I think of, who should govern these microgrids, these self-sustaining microgrids, should it be our utilities? Should it be, maybe it should be nonprofit? The profit motive, maybe it's time to revisit that. There are policies in place, regulatory policies that need to come down from on high, but there are also questions about, reuse of our beloved internet. Do we take it as is? There's a, as part of the Smart Grid NIST SGIP effort, there's been an analysis of kind of the protocols within the internet design that would be useful to keep, if you will, the sort of the core of the internet. And the question there is, this is a different operating context, and there are things that people like Vint Cerf have identified as really missing from that architecture. Authentication. There are whole groups of people also re-examining whether our addressing, routing, naming in the way of content-centric networking is suitable, is a better fit for these measurement infrastructures that we're trying to support here with Smart Grid. So some of the work that the NSF has funded in the past about clean slate, this is a wonderful opportunity to revisit it, because the Smart Grid cyber infrastructure may look vastly different than what's already in place in the internet. So I think that we should take advantage of that opportunity. So I've sort of said that one of the goals here is to create these sort of Smart Grid biospheres at a variety of scales, and to think about what how the architecture changes in order to support that. The other question that I've wanted to ask a lot throughout the day is really, how to get people to care about sustainability. And I mean, when I say people, I really mean people, businesses, governments in general. We have talked about the user, and I would say that our charter in our group is to really make this user-centric. From the user's perspective, how do you engender their help? Because if you wait for government to enact policy, you might be waiting a long time in the regulatory domain for things to come down as, you have to do this, you have to do that. So we could identify the places such as the home, the office building, the neighborhood where consumers have an impact. There's something like 150 million, about 150 million households in the US. There are about 260 automobiles. And so if you just looked at the impact that the end user could have on I think it's 35% of the US energy profile, rests in the hands of consumers, individuals. So they could really make a difference here. On the flip side, they're really impacted by resource usage, meaning you have to make the discussion relevant to them. They have to feel it. They have to have some benefit from buying into sustainability. So the easiest thing to do, of course, is to consider making energy more expensive. There, again, not enough discussion here. I mean, the economics are that, frankly, we don't charge enough for energy usage, and so people look at askance at it. Now, we have the luxury in a developed nation to be that way. In other places, they don't. We have talked a lot here about the social science to understand consumer attitudes. There was a very interesting paper that came out at CHI this year at ACM, Computer-Human Interactions, and it looked across 150 studies that that pretty much reconfirmed that people lose interest in managing their energy after some small number of weeks. And so if that's the case, you know, we have to get to the bottom of that. What's the root cause? Because if they're not going to be involved in this, we lose that potential. If we're going to study these, you know, basically personal energy management systems at the edge of the microgrid, the closer you get to people and their own personal data, of course, we've talked a lot about privacy and security, and there's this interesting tussle because on the one hand, you want to collect with your sensor infrastructure as much information as possible because isn't it wonderful? You could detect anomalous behavior because you've got all this historical information. It would help Homeland Security immensely. On the flip side, privacy wants to collect the information but not distribute it to very many people at all. And so one of the research issues is then how do we make it easy for consumers and users of this kind of system to specify the authorization. Who has authorization for this? And more devices are going into people's homes, and so the imperative is that you make it easy to configure and manage the device setup and the security for them because they're mere mortals, they're not IT departments. So the other goal here for our group is really create these trusted personal energy management clouds at the edge of the smart grid and hopefully do this in a self-sustaining manner. Thanks.